So today we are going to continue to do lesson 7.2. Instead of going to day 4 and doing the exact same thing with substitution, we're going to finish up day 3. If you still struggle with substitution, remember it's part of your responsibility for your learning. What you could do is look at day 4 and go to this link, and they would show you more examples from OneNote. They'd go through and do the rest of this. But we're going to finish up where we left off yesterday. So, substitution. Everyone should be on example 1. When we are solving with substitution, all we are doing is we have to solve in our equation like this first one, y minus 3x plus 2. When we have the equation that has 2 variables, we obviously can't solve it yet. So we want to solve for just one variable, and what it equals, we'll have the other variable. And then we're going to take that and substitute it in. So if we look at this one, I have the 2 equations, y equals 3x plus 2, and I have x plus 2y equals 11. Well, the nice thing is the first one that I've highlighted, it's already done for me. Y equals. So when I look at this, I know I can substitute 3x plus 2 for y. And hopefully that's all starting to make sense for you. Y equals. Y is. Whatever 3 times x plus 2 is, that's what 1y equals. So we are going to take that, and I'm going to go to my second equation, and instead of writing a y, I'm going to substitute 3x plus 2. It's the same amount, just written differently. So when I rewrite this equation, I would say x plus 2y. Y is 3x plus 2. I continue with my equation, equals 11. We would solve now. I distribute x plus 2 times 3x is 6x. 2 times 2 is 4. Equals 11. This is something I want to make sure everyone's hearing, because even on your test, I was seeing mistakes that were simple. Like terms. I cannot add the 4 and the 6x, because they're not like terms. This has a variable, this one's just a constant. So I look for my like terms. X plus 6x. That's like 1x plus 6 x's. 1 Chuck Norris plus 6 Chuck Norrises would give me 7 Chuck Norrises. So we would say,
why are we using Chuck Norris?
7.
Who's Chuck Norris?
Just use it as an example.
Who is Chuck Norris?
It's a guy.
So, when we do our like terms, we have 7x plus 4 equals 11. And then this is what we did a few chapters ago. We're just solving an equation. I minus the 4. I minus the 4 on both sides of the equal sign. 7x equals 7. We get x alone by dividing by 7. And we have x equals 1. So that is part of my answer. Part of my answer is x equals 1. But I still need to know what y equals. So people are like, well, y equals 3x plus 2. Great, but we want to simplify it all the way down. So how we do this with substitution, now that I've solved for one variable, I go back to the original, or to be honest, since I know what x is, I can go to any of the equations. I can substitute 1 in for x on y equals 3x plus 2, or I could put 1 in for x plus 2y equals 11. It really doesn't matter. I can do either equation. Usually it's a preference. You look and say, which one do you feel looks easier? So I'm just going to go to the first one. So I'd say, putting this first equation back in, I would say y equals 3x, but x is 1 plus 2. Notice the reason we use substitution is now in my equation I only have one variable. And we can solve for that one variable. 3 times 1 is 3. And then I'd say y equals 3 plus 2 is 5. That is my final answer.
Okay, so wait, never mind.
And let's go ahead, I'm just going to prove something. If I were to use the second equation instead of that first one, and I would have said x was 1, 1 plus 2y equals 11, I would have subtracted 1, 2y equals 10, divide by 2, I still would have got y equals 5. So I still get the same answer, it's just I used which one I thought was easiest. This is substitution. As long as you can wrap your head around it, it becomes fairly easy, and it's just doing what we did about 2-3 chapters ago, solving equations with a variable. Right now we have two variables, x and or put y and x. We use substitution, so we solve a problem with only one. So, example 2, I think we have a couple. So, I want you to go ahead and try doing this one. So, go ahead, I'm going to walk around, I'm going to pause my video, I'm going to see you guys working on this one. Can you solve it? I'm just going to help you make sure everyone's started correct though. My first step is I have to solve for either x or y. And when I do that, the first time, it's going to equal the variable in it. So when I look at this one, I'm going to see y equals 2x minus 3. Since y is alone, I'm going to use that. So we should be substituting in x plus 3 times y. Y was 2x minus 3. And it equals 5. Go ahead and solve for x. And then substitute it in for y. Okay, so Jordan went ahead and she came up and solved this one. Gentlemen, follow along with me now. So she distributed the 3, combined like terms, 7x minus 9 equals 5, added 9, 7x equals 14, divided by 7. Your final answer, she got x equals 2. I will tell you that is correct. X equals 2. Okay, who can tell us how do we find y now? What do you think?
I got it. So I used the top equation.
So you use the top one to redo this?
So I wrote out the top equation, but instead of putting an x, I put multiply by 2.
Okay. Y equals 2 times, and instead of x, you put 2 minus 3.
And then I multiplied the 2 together equals 4. So y equals 4 minus 3. And you subtract those to get y equals 1.
And that is correct. Here's the fun thing is, I always feel like substitution, the very first time getting your first variable, it kind of takes a while, it's kind of more difficult. Once you do that first one, then the second one's like really quick and easy. So it's really important that you slow down and do the first one really correct so you don't make a mistake, because that throws everything off. Okay, this one is in your foldable. So if you still have, I'll pull this open for you. The foldable, I gotta use this. Alright, so we did solving systems by graphing. We did that a couple days ago. Remember, you solved each equation for y, then you graphed each equation where they cross was your answer. We're working on solving by substitution, and here's the explanation in the rules. Let's, if you want to do that in your foldable, so you have that, that's great. Otherwise, we're going to do it right here. Now, this one is a little bit different. It's not set up as easy. Step one is always to solve for one of my variables. I want to try and choose one that has a coefficient of only 1. I have 2y plus x equals -4. Y minus x equals -5. First thing I notice is neither one of my equations says x equals or y equals. So I'm going to have to do some work to start off with. Which equation do you guys want to work with? There really isn't a correct answer. It's just personal choice. Devlin?
The bottom one.
Sure, let's work with this bottom one. Was there any personal reason why you chose that one, Devlin?
Because the variables don't have numbers.
Alright, so the variables don't have any numbers. If I did the top one, I could have done that and solved for x, because x had a variable or a coefficient of 1. But let's do this one. Which variable do you think I want to solve for? X or y?
X.
Y.
Y.
Y. The reason we want to solve for y, we could. But if I solve for x, since it's y minus x, if I got rid of the y, I'm going to have a negative x. So that's just another step I'm going to have to make sure I don't mess that up on. So if the first one's a positive number, I just use that. So I'm going to say add an x to both sides. So I'd have y equals x minus, I say one thing and I write the other, x minus 5. So we have changed that equation. No longer am I looking at the equation y minus x equals -5. I am looking at y equals x minus 5. Okay. Now that I know that y is equal to x minus 5, I'm going to go in to this other equation that I did not use and replace the y. So once again, I'm going to pause here in just a second. 2 times y. Y is x minus 5 equals, oops, hold on. 2 times y is x minus 5, plus x equals -4. You have to make sure you write the whole thing up. Okay, I'm going to pause again. Solve for x. I'm going to call someone up to do that, and then someone to help with the y. Alright, let's check Devlin's work. We distributed the 2. 2 times x is 2x. 2 times -5 is -10. Like terms, 2x plus x. Make sure you're paying attention to what sign's going in front of it. X was adding, so it's a positive. So that'd be 3x. You added the 10. You kind of showed that all in one step. I would have showed it two, but minus 10, so you added 10, so I'd have 3x equals -4 plus 10 is 6. 2. X equals 2. Very good job, Devlin. Okay. How do I finish this then? X equals 2. How do I do y? Who have I heard from? Miss Addie, you look pretty quiet. I pick on you. Abby, which equation do you want us to look at? I can either do the first one, 2y plus x equals -4. I could do y minus x equals -5. Or, since we rearrange, I can use the third equation, y equals x minus 5. Which is this one, y minus x. Okay, so we're going to use y minus x equals -5. And x is, so y minus 2 equals -5. What would I do? Add 2. Y equals -3. Alright? Now, I want to point out one part. I want to make sure everyone was clear on this one. When we substituted the x in, I told Abby, I asked her which equation does she want to use. Remember, when you substitute, you already found one of your variables. When you substitute in, this time you can use any equation. And usually we have our two equations. 2y plus x equals -4. Y minus x equals -5. I told her she had a third option. And the reason was, the very first step, when we first started this problem, was I rearranged this first problem. Instead of saying y minus x equals -5, we said y equals x minus 5. If you ever rearrange that, that also becomes an equation that I can use. It equals the same thing. If I would have put 2 in, I would have said y equals 2 minus 5. 2 minus 5 is -3. We would have got the same answer. So it's just using your personal preference. Okay? Is there a way we can always check? We're not going to do this right now because of time, but is there a way I can check to see if my answer 2 and -3 are correct? Eric?
You could try another equation.
What do you mean?
Like one of the other three equations.
Okay, I could. There's something else I could do.
Could fill in y and x with 2, 3.
Good. Let's substitute y and x in. Choose any of the equations. Actually, we will do this one because it's real short. I'm going to use the y minus x. Y, we said, was -3. Minus x. X is 2. Equals -5.
That's right.
-3 minus 2 is -5. Does -5 equal -5? Yeah. Then it means it's true. We did it correct. Alright, let's continue on. We have just a couple more, and then I'm going to let you guys work on your homework, I think. This one, also pass it out. We're going to start from the very beginning. I'm not going to help you do any of it. So, my two equations. 5x plus 2y equals 9. X plus y equals -3. Are any of them set up where they tell me what the variable equals by itself yet? No. So you have to do that first step. I'm going to pause. I want to see people working on this one, and then I'll have 2 people volunteer. All right, so start coming together. I like how a lot of you were working together and asking good questions. So, we're up here. Kate's going to be explaining what she's doing, it looks like. How'd you do the first one?
Okay, so I subtracted -x, and I got y equals -x minus 3.
Good. I had a number of people that kept messing that up. Remember, if I move a variable from one side to the other, I have to do the same operation. So if I minus x on the left, I have to minus x on the right. So y equals -x minus 3.
And then I did 5x plus 2.
Okay, so she's going back to the first equation now. Now that she has that y equals an equation, we went back to the first equation. 5x plus 2y equals 9. And instead of saying 2 times y, we substituted in that equation that she just found. 5x plus 2 times -x minus 3. You distribute that 2, you'd have 5x plus -2x minus 6 equals 9. The only thing I'll help with is, remember, if I have adding a negative, I could just say 5x minus 2x minus 6 equals 9. Okay. Alright, continue.
3x.
Combining like terms, 5x minus 2x is 3x. Okay, getting our constants on the same side. She added 6, so we have 3x equals 15. X equals 5. Kate? Great job, Brendan. Are you going to come up and do this one? Okay, so everyone, if you did not get your Keep your side. We're almost done. If you did not get x to equal 5, please make sure you're looking up here and see what mistake could you have made. Now what are you going to do, Brendan?
I'm going to put it back into this.
Alright. So he's using the equation y equals negative x minus 3. So y equals negative x. X was 5, so y equals negative 5 minus 3. Kind of cheating, isn't it, Kate? They make you do all the hard work. So, if you're looking up here, he substituted 5 in for x. X was a negative x minus 3. So negative 5 minus 3, y equals negative 8. That is your answer. Brendan. Okay, last one I want to do is a story problem. And there's a reason. Get used to, gentlemen, follow along please. We're almost done. You need to get used to, right now when we have some story problems, that it's not going to be one step. To solve a multi-step, you got to be thinking, I'm going to be writing 2 equations to solve this. So it says, Andrew has $2.10 in nickels and dimes. Oh, money, making it rain, nickels and dimes. He has 9 more nickels than dimes. How many nickels does he have? Okay, to find this, it's not just randomly guessing. The way we do this is nickels, I'm going to give that the variable x, and dimes, I'm going to give y. So get used to story problems. If I don't know something, I don't know how many nickels, I don't know how many dimes, give them both variables. Here's how I can set this problem up. My nickels, x, I don't know how many I have, and my dimes, oops, I'm going to do this. I need to be timesing up. How much is a nickel worth?
5 cents.
5 cents, right? Now, I'm going to put it in as a decimal unless I change this $2.10 into cents. So, if we do that, this will be easier. $2.10. I don't want to mess with the decimal. How many cents is $2.10? 210. So I'm going to just go to cents. So he has 210 cents. A nickel's worth 5 cents. So I'm going to say 5 times x. 5 cents times every nickel plus a dime is 10 cents. 10 cents times every dime. What will that equal when I put his nickels and dimes together? It has to equal 210. Can I find out how many nickels and dimes he has yet? No. But then they said he has 9 more nickels than dimes. So 9 more nickels. So what would be my equation? What do you think? It's probably not going to be the first one a lot of you think. How would I say you have 9 more nickels than dimes? Devlin?
D plus 5.
Oh, but we have x and y.
Oh, x plus y.
So which one? What?
Wait, what?
What would be the
That'd
case?
be y plus 5.
Awesome. Y plus 5 equals x. Remember, I keep wanting to write it wrong, but 9. Wait, why'd you say 5? Devlin? Should have been 9, not 5. 9 more nickels. So 9 more nickels. So my nickels equals my dimes plus 9. Because x and y are just how many do I have. We then have this equation to solve. X is y plus 9. So I could go in here and say 5 times y plus 9. I gotta finish my equation. Plus 10y equals 210 cents. 5y plus 45 plus 10y. I'm trying to go a little quick through this because we're almost out of time. We'd have 15y. If I minus 45 from each side, 210 minus 45 is 165. Divide by 15. Y equals 11. So this tells me I have 11 dimes. I have to go back in. 11 plus 9 equals 20. I would have 20 is X, so nickels. And 11 dimes. Okay, I went through the process fast. I just want to make sure we set it up right. Your homework, we are going to stick with this. 7.2, I gave it to you on Tuesday. We did evens, so let's finish up and we'll do our odds. So it would really been if you did your homework, you don't even be doing 13 more. If this is not enough room, can you use a separate piece of paper?
Yes.
Absolutely. This isn't enough room to be 100% honest with you. So, I would use a separate piece of paper, show all your work. Tomorrow, we will answer this and go over the third process.